Today's topic is traffic manager and Azure web app. So any idea about traffic manager and web apps? Have you ever heard this service in cloud? What do you mean by traffic manager? Or in general, have you heard what is traffic and what is manager? Okay. So no worries. So if you don't know what is a traffic manager, if you try to understand the word separately, right? If you try to understand the word traffic plus manager, it will clearly make you understand. So this is a service or a device which will manage the traffic. Okay. So what is that? What kind of traffic? It can be an application traffic or it can be any traffic that is requesting for a service. Okay. So that is a device. What happens normally we will give it for the applications. Okay, so that's why I have combined both traffic manager as well as Azure web apps. So let us try to understand what is a traffic manager now in deep. If you look at this slide, a traffic management, it's a device. Okay, it's a DNS based load balancer. In fact, okay, what happens? It will enable you to distribute the traffic optimally to the servers or the applications behind the load balancer. I mean the traffic manager. Okay, globally. So I think you are not understanding the definition, but I will try to make it very easy. Say for example, this Facebook application is there, right? So today you are in India and you are sitting at your home, you are connected to your Wi-Fi and try to access www.facebook.com, or maybe you have your application installed in your mobile. You just open the Facebook applications and start browsing and looking at the posting, reels, all those things you do, correct, right? So tomorrow, for some reason, you are traveling to USA for a business trip. So how will your computer should understand need to connect, or how will your mobile will understand I need to connect to a server which is there in India or which is there in America? Correct, right? That will be handled by the traffic manager. So this traffic manager means it's an intelligent device. What it will understand the DNS server based on your location. Imagine you are in India. I mean, the Facebook server is there in India, but you are there in the America. If you want to do some images posting, or if you want to upload some videos, when you click on upload, that image or that image or the video should travel all the way to India via network, and then it will start uploading it to the server. So this is a time consuming, and it also causes the delay and performance will be degraded. So to come out of such kind of issues, performance issues, and to have a effective performance and a better performance, so what we have done, we have in a service called traffic manager. So that traffic manager will sense where are you present, means whether the DNS server, I mean whether you are there in the America or India, that will be identified with the help of the DNS. And if that DNS server is there in India, it will redirect to the Indian server, and if you are hitting to the DNS server of the America, then it will go to the America server. See, I told you day one only. So when you talk about the Facebook as an application, so this Facebook is not a single server. It has got n number of servers. If you look at this image, imagine you are having a traffic manager on the top. You see here, you have multiple applications. One is in Northern Europe, another one is Western Europe, another one is in East Europe, East America, another one is West America. Today you are in North America, okay, and when you are trying to browse www.facebook.com, now the you are not directly hitting the application server, you are hitting the load balancer, or you are hitting the traffic manager. In our case, it is a traffic manager. So traffic manager will sense your presence based on the DNS resolution, and it will direct whether you are there in North America, it will send it to North America. If the DNS is getting resolved by the East US, it will send to the East America or East Europe. Okay, like that. So that is how this traffic manager works. So fine, sir, understood. Then what are all the features of the traffic manager? Why do we need traffic manager? We have a load balancer, correct, huh? To increase the application high availability, redundancy, and all. But I mean, why are we looking for a traffic manager specifically? You look at here. See, traffic manager will increase the application availability. Same, even the load balancer also does the same thing. Correct, na? But load balancer is a different topic. In the load balancer, you will specifically have to increase the application availability. Correct, na? But here availability as well as traffic, I mean performance also increase. And the in the load balancer, it is within the 2-3 regions. Correct, na? Means you have to specifically add the servers from this region and that region. Correct, na? So load balancer will randomly send the, I mean, it will never detect the presence from which region or which country the traffic is getting originated. It will chumma just send the application request for the backend pool. Maybe you have 10 servers, it will randomly send server 1, server 2, server 3. No, it doesn't identify, okay, this request is coming from America and I need to send it to the America application server only. If I send it to European server, there will be delay or performance will be degraded. So that much of intelligence will be having by the traffic managers. So traffic manager increases the application availability, the first and foremost thing. The second one increases the application performance. I just told you, okay. The traffic manager improves application responsiveness by redirecting the traffic to the right endpoint with the lowest network latency for the client. That's what I did. But in case of load balancer, it doesn't do that. Load balancer will simply randomly send the request to the backend pool. No matter if you have 10 servers, one time it will send it to one different server. But in case of traffic manager, it is not like that. Traffic manager will only send the application, the queries or request only to the particular or traffic originated location. Say for example, you are there in, consider you are there in Karnataka. Karnataka is a region if you consider. So there are 3 servers. One is in Bangalore, one is in Mysore, another one is in Mangalore. Okay, another one more is in Hubli. Okay, so you are there near Davangere somewhere. You are trying to access the application. So the traffic manager will understand. Okay, is there any? I mean, what is the nearby location? Is it Hubli or is it Bangalore or Mysore? So based on the DNS resolution, it will understand, okay, I have a close by server either Hubli or Bangalore because Mysore is too far. So it will, based on the network length or the network node or the network latency, it will send the request to that particular server. That is what extra intelligence in traffic manager has got compared to the load balancer. And it performs a service maintenance without the downtime. Means if you want any kind of service maintenance, say for example in that particular region, you are updating an application or maybe you are deploying some other inside the patches and all, so it will never keep you down of the application. It automatically maintains the performance or the service maintenance without the downtime. It's all online activities. And the traffic manager works at the DNS level. But the load balancer, it does not. Load balancer works on a principle called 5-tuple hashing algorithm. It will only know which source, which port, which destination, which port. Only 4 points. Correct? And which protocol, 5th point. It will only look for those 5 points. But traffic manager will look the traffic is getting originated in which region and which DNS it is now getting resolved. Then it should understand which application servers I need to send the query. So these points are extra when compared to the load balancer along with the traffic manager. Now you have got a clear understanding. A traffic manager means it's a DNS based load balancer. Okay, this is also kind of a load balancer, but it is a DNS based, right? And it optimally sends or distribute the application request according to the region or the DNS resolution. Okay, so it's a DNS based traffic or the load balancer. Okay, that's about it. Any question with the first slide? Okay, you imagine this picture. Okay, if you imagine this picture in your mind, we have one application called facebook.com in this example. So there are 4 application servers. Those are deployed in North America and North Europe, Western Europe, another one is in East America and West America. If you look at all these 4 application servers are added behind the traffic manager. So when you are typing www.facebook.com, you are not hitting directly to the application server which are there in Europe as well as North America. You are not directly hitting. You are hitting, or your application request is hitting to the traffic manager, because traffic manager will have an IP address, traffic manager will have a URL, okay, and we will create the, for that URL we will create some DNS address. Okay, whenever you are typing www.facebook.com, we will create a DNS record for this traffic manager, and we will add that will have an IP address. So behind it we have 4 application servers. So this traffic manager will sense when the request comes, okay, it is coming from the Northern America or North Europe. What I have to do? I have to send this request to the application server 1, app service 1. If the request is coming from Western Europe, then the request should go to the app service 2. If the app service 2 goes down for some reason, then it will send it to the app service 1, which is in North Europe. The same fashion go for the other way around. I mean, the North America side also, we have the app service 3 and app service 4, right? So this is how a traffic manager distributes the load or application request. So there are a couple of more methods are there. You may ask a question, how do a traffic manager will understand, sir? Okay, then the question for that we have in the next slide answer. So traffic manager routing methods means the traffic manager also working on some kind of routing methods. So there are close to almost 6 types of traffic routing methods are there in case of traffic manager. The first one is priority. Means you need to define the priority. So use a priority endpoint for all the traffic and provide a backup in case the primary endpoint fails or unavailable. Means there are, say for example, in this example, I would request always the request should go to North America. That's my priority 1. If North American app service 1 goes down, then go to the app service 2. Same fashion, if the North America side, if anybody is accessing the application, it should first go to the app service 3. If app service 3 is failed or having some issue, then only the application redirection should happen for the app service 4. Okay, that is how, and that is what we call as priority based routing method. Next one is weighted. The weight is an integer number. Okay, see you can give the weight like 1 to 1000, the number will be vary. Okay, and you can tell, okay, the which is first, which is second, which is third, and which is fourth. Like that, depend upon the weightage number or weight number, the traffic routing will happen. You, while creating the traffic manager, it will tell you what is the routing method. You can select like weighted, it will tell you for what is the weight for app service 1, what is the weight for app service 2, and what is the weight for app service 3. Low, say for example, in my case, imagine only 2 applications are there. You can, or 3 applications are there, or 4 applications, no matter how many applications you have. You can give, okay, this is for 1, this is for 2, this is for 3, this is for 4, or 100, 200, 300, 400. Lesser the weightage, higher the priority. Higher the weightage, lesser the priority. See, wherever you have less weightage, the application should get redirected there. Where you have more weightage, the application will be sent finally at the end for the last one. The same method here. And the performance. If you just select the performance, then that is the actual. The performance and the geographic are the actual one. Okay. So it will directly send to the closest endpoint. See here, the closest endpoint in terms of the lowest network latency. I told you, you are there in Chitradurga or Davangere, and you are trying to access an application called facebook.com, and that traffic manager will check the network latency and the distance, how many number of hops are there between your endpoint or your computer or your mobile and the application server or the traffic manager. So based on that, it will just decide and send the traffic to the respective traffic manager. Okay, and the distance, it is not the geographic distance, it is the network distance. how many number of hops are there between your mobile application and the application server which is hosted in the AWS, or depends on that. Okay. Next one is geographic. So I told you, geography. Today you are here in India, tomorrow you are going to America. So your traffic manager will sense, it will understand where are you. So which DNS server is helping you to resolve the Facebook queries. So then according to the geography, it will send. Okay, that is the geographic one. So multi-valued. The multi-valued traffic routing method allow you to get multiple healthy endpoints in a single DNS query response. Means it will always randomly send here and there according to the healthy endpoints. It is similar to the load balancer only, but it will also consider the location based on the region and network latency and the distance. All these things it will randomly send one at a time. If the 100 queries coming, maybe 2 queries will go to app service 1, 2 queries will go to app service 2, like that it gets distributed. 20% will get distributed. Okay, one after the other. And the last one is subnet. See, the subnet traffic routing methods to map the set of end user IP address. You can define. Okay, so I have the users across the 4 region, or both European and North America. I have from 4 different locations this application will be accessed. So what you can do, you can tell, okay, user will hit the traffic manager anyway, no matter what kind of routing method you have. User will directly hit the traffic manager. So traffic manager, if you decided, okay, the routing method, like if the, say for example, if the user's IP address is starting with 192.168.1.0/24, then the traffic should go to the app service 1. Whereas 192.168.1.1.0/24, then it should be Western Europe. Or if it is 172.16.1.0/24, that is Eastern, the app service 3. So depend upon the subnet from which range the users are coming from, which network range the users are hitting the application. So the traffic manager will decide and send all the query to a single server. The entire subnet users will be redirected to a particular application service or app service. It depends upon the subnet. Okay, that is called as subnet based routing method. Okay, any questions here? Okay, so that's about the traffic manager. Now you know about the traffic manager, the top one here. Okay, the top one. But let us understand this. What are these web service or web apps? Okay, we will call it as web apps or app services in Azure. See, normally what happens if you want to build an application in the on-premises world, or Azure infra as a service world, or virtual VMware or virtualization platform, what you have to do, first of all you have to install a Windows Server operating system. Either it can be a server 2016, 2019 or 2022, whatever the latest operating system you have, or at your office whatever licenses you have procured, depend upon that, or the application compatibility, okay, what version of operating system you wanted. You can build a server. Once you build a server, you will install the Internet Information Service, the IIS Internet Information Service into that server, and then the developer will develop some application package. And what do? We will just deploy that application package to that particular app server. Correct, na? Then you will create some DNS entries and you will bind some certificates. Then the application will be start launching. Correct, na? So, but in case of web app, it is not like that. See, whatever I have just explained, it is infra as a service. But in cloud, we have multiple services called infra as a service, platform as a service, or software as a service. So this app service is there. This is a PaaS services, means platform as a services. here you don't need to manage the server. What is the difference between a infra as a service and the platform as a service? The difference is, in the infra as a service, you have to deploy a server, you have to install the application, you have to configure application, and also you need to do the maintenance activity, means restart of the server, or patching of the server, update of the server, operating system upgradation, licensing, everything should be taken care by you when you opt an infra as a service. But in case of web app, it is not like that. Web app, we call it platform as a service. So Microsoft will take the burden or of administration burden of your server, everything. They'll take care of your operating system, they'll take care of your server, they'll take care of their upgrade activity, patching activity, everything will be taken care by them. They will only give you the app. You can directly deploy the app without having a server or without managing a server. That is called as app service. See, an app service is a PaaS service for hosting the web application. Okay, I just told you PaaS is a service. App service is a PaaS service. It will help you to host an application. And what kind of application you can deploy? You see, the REST APIs are a mobile backend related applications. You can even develop in any languages. So this web app will help you to develop the application in any of the languages that you wish. It will support .NET, Java, Ruby, Python, PHP, Node.js, blah blah blah. Any services or any language that you pick up, the web app will support. That is why it's platform as a service. Microsoft is giving you the platform. You develop the way you wanted. Develop the app, deploy the app. That's all. Develop the app, deploy the app, and use it. That's all. And what is the benefits of the app services? You see here, multiple languages and frameworks, means it supports multiple language and it will also supports multiple frameworks. Say for example, you have some application consistency, okay, that application should be written only in the ASP.NET or only in the Python. No matter whatever language you wish to have the application, it will support. So first and foremost, it's a multiple language supportable framework. And it supports DevOps optimization, means it's a very quicker one. Earlier we were using the waterfall method. That time somebody was developing one portion, somebody was developing another portion of the data, then they were clubbing together and they will make one application, then they will call for the testing, okay, regression testing and performance testing, many other testing they do, and then they will launch or make the go live of the application in the waterfall method. There they used to take months and years of time to develop an application. But in case of DevOps, it is not like that. In the DevOps, we work on agile methodology, means everything is agility will be there, means it's a very quicker. You need an application within 1 or 2 days or maximum a week, you will have the application ready. Okay, that is why you see in the mobile applications or whatever applications nowadays, you get updates very frequently. If you go to WhatsApp, you will have the update. If you go to phone pay application, you have the update. Correct now? Why? Because the developers and the operational guys comes together and they work together and develop something, and that too in the sprint based, like 1 week of sprint and 2 weeks of sprint they will do, and whatever code they have ready, developed, right, they don't need to wait for the entire application to be make ready. You can just push that particular code. Say for example, if you consider Facebook as an application, the Facebook has multiple features. It will allow you to post some your photos, comments. It will allow you to look at some videos. Okay, it will allow you to know marketplace also. Nowadays they are giving marketplace, correct, right? So say for example, in the marketplace, while uploading some images or videos, it was not, it was getting hang. The computer was going unresponsive. Okay, it is not responsive. Okay, so you have a bug there. You don't need to wait for everything to looked up. You can only go look at the code of that particular marketplace and revisit the code and just push the update. So even though the users are using the Facebook application, it will just comment, the update will comment it in the marketplace or the app store. So what you can do, then you can, if you wish, when you have time, you can just update it if you want to fix it. That is how this DevOps supports, means continuous integration and continuous deployments. Whatever code is ready, you can directly deploy that. You don't need to wait for everybody to confirm. You can just release the code as soon as it is ready and tested. Okay, that is DevOps. And global scale with high availability, scale up or scale down can be done manually or automatically. Means these applications we have, right? These applications similar to the infra as a infra word, like you have CPUs and memory. Even this web applications will also have CPUs and memory. Sometimes if the application goes beyond the performance limit, okay, beyond the performance limit, so you can define, okay, if my application is receiving more than 1000 requests per minute, you can scale up your application configuration, means your app service, from 2 CPU to 4 CPU and 4 GB memory to 8 GB memory. Like that you can define. And you can also define if the per minute user less than 500 or 100, then reduce the size by 2 CPU and 2 GB memory. Like that you can define. The scale up and scale out, scale in and scale out will happen automatically, but you can even do manually, but it supports both. And connection to the SaaS platform and on-premises supports, it is very easy. If you want to connect, no matter whatever the media you have, like any kind of applications or any kind of APIs or any kind of cloud for that matter, for every cloud it supports. Okay, that is a platform. And security and compliance, authentication of user using the Azure AD as well as the social login for Google, Facebook, Twitter, etc. Means it is not necessarily you will have a user created to access an application. So nowadays you have a lot of things are coming, a lot of Gen AI and Chat GPT, AI tools, everything is coming. So when you are signing up first time, it will ask you, would you like to register or you would you like to join? Would you like to log in with your Facebook account or Google account or Twitter account? Okay, that is what leveraging the social logins means. You can leverage your Google account, Facebook account and Twitter account to log into an third party application. Okay, along with that it will also support your Azure AD and on premises Active Directory authentication as well. Okay, that is the security and compliance. Means without allowing or without collecting the basic information, it will never allow you to log in, but it will give a lot of options. If you want a tight security, go with Azure AD or on-premises AD. If you want any basic information, I would like to know what's your name, what's your last name, what's your email ID, and what's your date of birth. Basic information what you give during the Google and Facebook account creation, those information it will collect and it will allow you. It depends on you how much restrictions you need to give. Okay, that is about the security and compliance. And it will also templates, supports the ready-made templates and kind of templates based deployments, like you have Joomla, you have WordPress and Drupal, everything is there. Okay, that will also supported by that application. You already have some templates. Now if you go to Wix, something website creation is there, WordPress is there, you can just do drags and drops. Already templates are there. You just have to key in, okay, what's my website name, what's my introduction. Those templates are already there, you need to key in. So such kind of application templates can be used to deploy an Azure web app. It will support that kind of templates as well. And the last one is Visual Studio integration for creating, deploying and debugging. Means you can use codes, Visual Studio or VS Code, whatever is there, you can leverage and just add the plugins, the add-ons, and you don't need to worry, you don't need to write the codes. Just right click and add a web app. It will just give you the templates, the code, the complete code for the web app. You just have to rename it and the parameters and the variables has to be changed. Rest everything is there. You can even customize it. Okay, so these are all the benefits with respect to the Azure app services. Okay, any question here? Okay, so this Azure app, now you know what is Azure app and what is the benefits of Azure app. But if you would like to know more about the Azure app and it has got some components also. We have app service plan, and how is the costing, everything we can speak here. If you look at this, Azure App Service Plan defines a set of compute resources for a web app to run. Means an app service plan, like you have a mobile recharge plan. You are recharging 250, 249 rupees. You get 1 GB 30 days. Similarly, if you recharge for 399, you will get unlimited calls, unlimited data, up to 2 GB. After 2 GB, the speed will be reduced, but you still have the data. Correct? Na? There is no restriction, no roaming free like that. So in the app service also we have a different plans. Such plan is nothing but app service plan. Okay, what does this app service plan will have? It will have the compute resources for a web app. Means how much CPU memory or which region you want to deploy this particular application, that will be captured as a plan, that is called as app service plan. So each app service plan will have certain information. You need to know the region in order to create the app service plan. Okay, when you are creating the app service plan, it will ask you in which region you want to create the app service, and then how many number of instances. I told auto scaling means it will automatically increase and decrease the number of app services. So while you are deploying this app service plan, you can tell based on the condition, minimum should always run 2 app services, maximum go up to 10 app services, but depends on the trigger condition. If my first and second app service, both app services are reaching 90% of the utilization CPU memory, then trigger in one more. Then if my 3 servers are more than 90%, then trigger the fourth one. Like it goes up to 10. 10 is a max. After 10, it won't do anything. See, normally all these configurations will be planned based on your historical information. Last 1 year or 5 year, how is my application is performing? Based on that only we will design the application. So it won't cause any issues. But soon after the users are getting reduced, then automatically it will shut down 111 app services. Okay, an app service will have such defined parameters here. It will have a region, it will have number of virtual machine instances, and size of each VM instances. I told you number of VMs, 10 VMs. What size I should deploy? I should deploy M32, M64, E16, E32, E64, the huge computers like M128. No, this M129 are very costliest virtual machines in the cloud. Okay, so it is not like that. It depends on your requirement. Okay, you can select the D series, B series, like that, depends on your requirement. And the pricing tier, what kind of pricing you wanted? Would you like to go for a pay as you go, or do you have any savings plan, or you have some reservations also? It depends on that. Okay, that is about the app service plan. Okay, so that's about the app service plan. Now if you want to know web app pricing tier, I told you have pricing. I mean the price will be depends on different pricing tier. Okay, so there are 3 pricing tiers with respect to the app service plans. The first one is shared compute. So in the Microsoft, there is an option called shared compute when you are deploying applications. So they have a big application server at the data center which has got 16 CPU, 32 GB memory. Okay, what they will do, they will give this option called shared support model or shared compute model. What they will do, instead of dedicatedly keeping a server to you, they will keep one big server, and they will place multiple applications in the same thing. Multiple, say I requested an application, you will allow me to put somebody, my friend will try to put one application server. They will allow, Microsoft will allow them to have the application in the same server. Similarly, some other vendor will try to have an application web app service. They will allocate all the service, I mean web apps, in the same server. Means it's a shared compute. Single compute will be shared for multiple app services. That is called as shared model. Okay, normally what happens if you go to any kind of outings or any kind of things, right? Or they will go, if you just go alone, they will charge you more. If you go like 5 people or 10 people, a group of people, then they will reduce the cost. The same option here. If 2 or more people are consuming the same compute, you can share the price, but you have to compromise with the performance. So okay, if it is a performance based application, like an application is there, that is a money minting application, like every second buying and selling will happening, e-commerce website for example, Flipkart, Amazon, for that example. Okay, if the, say for example, during the big billion day, you have per minute about 5 to 6,000 users will do the transactions. More than that, I'm just saying, giving an example, more than that will happen. Imagine if a transaction is completing within 10 milliseconds or 100 milliseconds. So the more number of user will come into the Flipkart and they will just do the shopping and they will get exit. If the application is not responding properly, then they will start sending messages, it is consuming too much of time. Yeah, I mean, and I did the payment, but the payment is not still showing, it is still showing loading. Then what will happen, people will not come to the website. It's a business loss for them. Correct, right? So if you have such kind of applications launched or hosted, probably what you can do, you can go with a dedicated or isolated one. Better dedicated. Okay, dedicated is good, means you will have your own application server. WebApp is hosted in your own separate compute. It will have your own CPU memory. Nobody will use this, whether you are use it or lose it, whether you are using it or you are not using it, not a problem. You will have a dedicated instance deployed there. Okay, that is the dedicated. So cost, it is a little bit costlier compared to the shared one. And the last one is isolated. So isolated means this tier runs dedicated Azure VMs on the dedicated Azure virtual network. Means if you don't want to expose some applications, some applications to some certain network, say for example, I don't want anybody to access from Pakistan. I have an application and I don't want anybody to access my application from Pakistan. What I can do, I can create a virtual network in the cloud and I can tell I can only access the application from the respective network, not from the other network. Like you can just isolate it. Maybe in your homes you will have your separate rooms. Actually no, you will not allow anybody there because it's your place, correct, where you feel relaxed, where you feel comfortable, correct na? The same fashion, the web tier pricing will also have three things. Now shared compute, where you can share the resource with multiple users or an applications. Dedicated, you have your own dedicated CPU memory. And isolated, it will only work allow you to connect from a particular network. That is the web app pricing tier. Okay, so that's about the app service plans. Okay, so with this we are done with the theory of both traffic manager as well as the Azure web app. So let me stop the recording and then I'll take the questions.